Hello, welcome back. It's been a while since I seen you guys. This video, we'll go through chapter business. Okay, we got 25 questions, and let's get the ball rolling here. It says, use the graph of the parabola to fill in the table. Okay, we could do that. All right, so just to kind of get some things out of the way it looks, it is open upward. Does find the equation of the axis of symmetry. So every U-shaped graph, or for a fancy name, parabola, has an axis of symmetry. And this imaginary line that we see here is the axis of symmetry. Okay, it is a vertical line, so therefore here we want to type x is equal to 2. Now, how do I know that this is the axis of symmetry? It is the axis of symmetry because it splits this U-shaped graph in half. The left side will be exactly like the right side. The vertex. Okay, so the vertex happens to be this point right here. For this particular example, because it opens upward, then the vertex is a minimum. Not necessarily that we're looking to answer this, but the vertex should be, okay, let me try this one more time. Since the parabola opens upward, then the vertex will be the lowest point of the parabola. And in this case, it happens to be 2, 0. Find the x-intercepts. Okay, so in this particular, okay, so it says find intercepts. For the x-intercepts, well, we notice that in this case, that's where it crosses the x-axis, so that will be the x-intercept. There's only one, so that happens to be at 2. The y-intercept, that will be here. Okay, and in this case, we just want to write, so let me write here that is the y-intercept. Okay, so is the value 4. Okay. Question 2. Find the x-intercepts and the coordinates of the vertex for the parabola given by such and such and such. If there is more than one x-intercept, separate them with commas. All right, let's get down to business. To find the vertex, okay, we're going to use this little fancy formula. Be negative b over 2a, and then f of negative b over 2a. Let me explain. If we have a parabola in standard form, ax squared plus bx plus c, this is what we refer to as it is in standard form, then the vertex can be found by using this formula. Don't forget that the vertex happens to be an ordered pair x comma y. So this part of the formula will tell us what the x value is. And once we know the x value, we can plug it into the equation to find the value of, in this case, y. Okay, so let's go ahead and do that now. So let's find that the x value of the vertex will be negative b over 2a. That happens to be that the x value is negative. This is b right here. So negative 8 divide, ooh, I could do that better. Divided by, I could do that better. That's better. 2 times, this will be A. So that was A, that's B, and that's C. Negative 1. So we get positive 8 divided by negative 2, which gives us negative 4. So now we know that the vertex has x value negative 4. Let's find the y value. y is going to be equal to negative x squared. So now we know that that's negative 4 squared minus 8 times negative 4 minus 7. That is equal to negative 16. Why do I say that? Negative 4 squared is 16, and there's the negative on the outside. Negative times a negative is positive 32 minus 7. This gives us, that will be 16 minus 7, which is equal to 9. So the vertex will be at negative 4, 9. Just for a little extra piece of information, the axis of symmetry will be x equals negative 4. Again, this is just extra. It wasn't really asked in the question, but might as well, since we found the vertex, might as well say what the axis of symmetry will be. Alrighty then. So the x-intercepts. Ooh. To find the x-intercepts, we need to solve the following equation. Negative x squared minus 8x minus 7 is equal to 0. And the reason we're doing that is an x-intercept is of the form some value for x, 0 for y. So notice that in this case, y is equal to 0, and we're trying to find what are those values for x. All right, so I think I would like to multiply everything by negative 1 because it just makes it a little bit easier, okay? And so here we're factoring, and so 7, so that will be, this is going to be relatively simple. That will be 1 and 7, and 1 and 7 add up to 8, so we have x plus 1, x plus 7 is equal to 0, and then x plus 1 is equal to 0, and then x plus 7 is equal to 0, minus 1, x is equal to negative 1, minus 7, x is equal to negative 7. So the x-intercepts, and I think all we want to do is kind of list them out, will be negative 1 and negative 7. Okay? Alrighty then. Let's see. So this will be the x-intercepts. Okay. By the way, I think if we wanted to ask, let me use a different color because this is not part of it. Okay. But if we were also asked to find the y-intercepts, they are of the form 0 for x, some number for y. So what happens is that this is so easy. We take x and we write 0. And then we figure out what this is, and this turns out to be just negative 7. So this was also an addition. Okay, so this was not part of the problem. We found the x-intercepts, we found the y-intercepts, we found the vertex, and a little extra, we found the axis of symmetry as well. Alrighty then, let's move on to the next question. Okay, let's get rid of this. It says that an aircraft factory manufactures airplane engines. The unit cost C depends on the number of engines made. If X engines are made, then the unit cost is given by this formula. What is the minimum unit cost? So these situations usually ask to find vertex. Okay. These situations are just asking to find the vertex. Okay. Notice that this function of cost is a quadratic function. And so then don't forget that we need to find the vertex. And so in this particular case, I think it says that X is the number of engines that are made. So what is the minimum unit cost? So when we answer this question, okay, the fact that they're asking for cost is that they're asking for the Y value of the vertex. Because we need to find the x value. In this case, we're finding the x value so that we know how many engines are made to minimize the cost. All right, let's go ahead and do this. All right, so the vertex will be like this, negative b over 2a. And then whatever that turns out to be, we'll plug it into the formula. But let me go ahead and use c in this case, since it has the name c. And so let's go ahead and do that. So to find the first value here, that will be negative 432 divided by 2 times 0.09. Okay, I am just going to use the calculator at this time. And so hopefully you have your calculator as well. And again, you're probably not seeing the typing of the keys here, but that is okay. So we have negative and a negative makes positive for 432 divided by 1.8. And so we get 240. So far, what do we have? According to this formula, the making of 240 engines minimizes the cost. So now we need to find C of 240 to find this value, which is the one that we need. And so that would be C of 240 is equal to 0.09 240 square minus 432 times 240 plus 65,297. All right, time to use the calculator again. 0.9 times 240 quantity square minus 432 times 240 plus 65,297, and that get a total of 13,457. Okay, so what is the minimum unit cost? And the minimum unit cost is 13,457. All right, then let's move on to the next problem. Number 4. For each function, determine whether it is a polynomial. Okay, polynomial. Polynomial. It is a sum of terms that looks like so. So let me just do that here. Plus that. Plus that, plus let's put here just, I'm going to just do a1x plus a, okay? So what happens is that each one of these terms, each one of those terms, all right, the idea is that x, let me just say it like that, x is raised to a power where this is a positive integer. Positive. So as long as all the exponents, that's probably the easiest way to explain this, as long as all the exponents are positive integers, then it is a polynomial. So look at this. That's not a positive integer, so it is not a polynomial. Look at this. That is the same as 8x raised to the power of 1/2. So therefore, it is not a polynomial. This is the same as negative x to the negative 2 power. Not a polynomial because it needs to be a positive integer. Positive integer. Oh, check this out. It is a very simple polynomial. And therefore, beam. It is a polynomial. All right, let's move on out of this. Suppose that the polynomial function f is defined as follows. List each zero of f according to its multiplicity in the categories below. So apparently there's some things that are not being printed out. So I guess we just have to kind of just go with the punches here. So let's see. But let's see. Okay, so I'll tell you what's going on here. Okay. Zeros. Okay, so the zeros will be the following. Okay, check this out. Notice these things inside of those parentheses. Well, those are going to help us find the zeros by doing such. So 1 0 is 6. Another 0 happens to be -9. And another 0 happens to be, in this case, 11. Let me use a different color now. Let me use this one. But you notice how this particular binomial, or let's call it a factor. Let's call it factor 1, factor 2, factor 3. Okay. So it was broken up into factors, and this particular factor is being raised to the second power. So that means that this 0, the 0, which happens to be 6, it has multiplicity 2. What does that mean? If you missed this, what you were going through the lessons, that means it's repeated 2 times. If we look at this second factor, which is x plus 9, it's just being raised to the 1 power. So the 0, -9, it's only repeated once. So it's just 1. When we look at the last factor here, which is x minus 11 squared, the 0, 11, has multiplicity 2. In other words, it's repeated 2 times. Okay. Alrighty then, let's see what else is going on here. Choose the end behavior. All right. You remember when we talked about a polynomial that I said something like it is a sum of terms dot 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 something like so. Okay. So what happens is that when we want to talk about the end behavior, we really want to focus on the leading coefficient. And so why? Why? Well, the exponent, which happens to be n here, tells us a whole lot. Okay, the exponent tells us a whole lot. Let's see if I can make a nice little chart here. Okay, so the exponent tells us a whole lot. Okay, so what happens if it's odd greater than 1? What happens if it's even? It's got to be positive. So like, what happens? Well, let me start with even. If it is even, then the graph is going to look like so. Oh, let me stop for a minute. The end behavior will be something like so. Something's going on in the middle there, blah, blah, blah. Okay, so the end behavior will look like so, as long as A is positive. Get rid of that. Oh my gosh, my handwriting is atrocious. As long as A, oh, and I cannot even spell positive. As long as A is positive. But what happens if it's negative? Well, then the thing will look like so. So the end behavior of a polynomial with an even leading exponent will be like so when A is positive or when A is negative. So what happens when it's odd greater than 1? All right, so if A is positive, the end behavior will look like so. Okay, and if it's A is negative, it will look like so. Okay. So, okay, let's just go ahead and take care of this. Look at this polynomial and look at that leading exponent. That happens to be a 4. Okay. So it's going to be an even. We look at the leading coefficient, and the leading coefficient is positive 1. So let's see, A rises. Oh, okay, so it rises to the left and it rises to the right. Okay, so in this case, both ends are rising. Look at this polynomial and look at the leading exponent. The leading exponent is odd, greater than 1. And so we look at the leading coefficient, which is also positive. So that means it falls to the left, because this will be falling to the left, but it is increasing or rising to the right. Ooh, this one's tricky. I am going to count the exponents, and that makes it equal to 4. So that means that this is a polynomial with a leading exponent of 4, okay? And the leading coefficient will be negative, okay? So that negative tells a whole lot. So in this particular case, both ends will fall, okay? Both ends will fall. Alrighty then, hopefully that was semi-clear. So I am going to move forward here. It says, find a polynomial of degree 5 that has the following zeros. 1, 2, 3, 4, 5. Okay. So the polynomial will be x plus 3, x minus 7, x plus 2, x minus 6, x plus 5. Okay. And I don't want to be the bearer of bad news, but I think this thing is going to want us to multiply this out. So I'm going to multiply these two quickly. That will be x squared minus 4x minus 21. I'm going to multiply the next two, and that will be x squared minus 4x. That will be minus 12 times x plus 5. I'm just going to take care of this right now, which will be, in this case, that will be, let's see, x cubed plus, or let me take that back. Yeah, plus 5x squared. And then we have this one, so that will be minus 4x squared minus 20x minus 12x minus 60. Oh, I'm running out of room. Okay. And so I'm going to try to combine this. This will be x cubed plus 1x squared minus 32x minus 60. And then I'm going to try to multiply this with x squared minus 4x minus 21. And this is just becoming a very laborious example, but I'm just going through it. That will be x to the 5th power. That will be plus x to the 4th minus 32x and try to do something systematic here. This will be, let me just erase this. So now I'm doing this one. So that will be minus 4x to the 4th. That will be minus 4x cubed plus, that will be 120 plus 128 plus 128 x squared. And then we have negative and a negative, that will be positive 240x. All right, now finally, the last thing, we have negative 21x cubed. We have negative 21x squared. Okay, I'm just going to use the calculator here. Negative 21 times 32. No, I did. Oh, yes. 21 times 32. I get 672. So positive 672x. And then 21 times 60. I get 1260. And then I'm going to combine all these. And I get x to the 5th. I get minus 3x to the 4th power. That will be 32 and another 4 and another 21. I get negative 57 x cubed. We got negative 60 plus 128 minus 21, and I get 47. So plus 47x squared. Plus, let's see, that will be 211, and that will be 912x plus 1260. This is probably the one example where I probably made a mistake on my arithmetic. Please double check that, okay? Please double check that. But I should have checked the solution because maybe I didn't have to do all this. But I don't know. I will have to check the solution. Because we would have been done here. This would have been perfectly good. This would have been perfectly fine. There's nothing wrong with that. Okay. But I think this thing wants the thing multiplied so that it looks like so. All right. Maybe we can change the exam and maybe look for something much easier than whatever I just did there. Okay. There's still time to change the exam. There's still time to change the exam. Okay. So that maybe that example looks a little bit easier. All right, let's go ahead and do this division here. And I am very glad that we are dividing by this type of binomial because I am going to take care of this example using synthetic division. 1, 1, negative 25. If you haven't seen synthetic division, it's a very useful technique when we are trying to divide by binomials that look like so. Okay. Notice that you see here a plus 6. I'm using a minus 6. And where is this 1 and 1 negative 25 coming from? It's coming from the coefficient of x squared, the coefficient of x, and the constant. So did you notice that I did an arrow here? And the reason for that is because in order to start synthetic division, we always drop the very first number. And then we multiply, so we get negative 6, and we combine. Combining these two numbers gives us negative 5. Multiply again, always multiply bottom with this number. So we get a 30, and then we combine, and we get positive 5. So what is the quotient? The quotient will be, well, let's start with this. This is the remainder. That's the remainder, so that's going to be a 5. Okay. And then this will be the constant, and this will be the coefficient of the x. Okay. Remainder, constant, and then this will be the coefficient of x. So the quotient is x minus 5. All right, moving on. What I'm trying to do is trying to move as quickly as I possibly can because I know I got 25 questions to go through, and I'm trying to get it done in 1 minute. I mean, in 1 minute, in 1 hour. So hopefully, let's see. Oh, what was that? I don't know what this is. Please, let's get rid of that. Let's just not mess with this. Okay, let's not mess with this. It doesn't really say how much we've been recording. No, it doesn't matter. Let's just keep going. All right, so here, synthetic division. 3 times 3 is 9. Combine, we get 13. That will be 39. Combine, we get 48. And then 48 times 3, that will be 120. Okay, let's just do 48 times 3. 3 times 4 is 3 times 8 is 20. Yeah, 24. 3 times 4 is 12, and that will be 144. So we get 144. So we get 155. And so the answer here is this is the remainder. This is the remainder. That's what goes here. This is the constant. This is the coefficient of x. And this is the coefficient of x squared. Okay. All right. So we have 3x squared plus 13x plus 48 plus 15. Okay. 15 over x minus 3. This is a little bit of misleading because it shows like a whole bunch of stuff, but there were only 3 terms in the quotient. So this is a little bit misleading, and hopefully it's not like that on the exam. Okay. Alrighty, then let's move on. See if we can go ahead and go back to black ink. Okay, looks like you're sharing your videos or animations. I want to include computer audio while you're sharing. I'm not sure what that means. I hope I'm sharing my audio. Oh, use the factor theorem to determine whether x plus 3 is a factor of that. Okay. All right. So in order to do this, okay, to determine if this is a factor of this polynomial function, then we need to know what happens at -3. Okay. And so then using synthetic division, let's see, I got the -1. We got the -2. There is a 6, 0, -3. And you're wondering why I put a 0? Because we need to make sure that everything is accounted for, and the linear term was missing. So it must have had a coefficient of 0. The idea is this, that if it is a factor, then right here at the very end, that will be a 0. Let's see what happens. -1, we get 3. Where is the 3 coming from? With times. We get a 1. -3 because we always times. Here is always times. Bottom times the top. Combine, we get a 3. 3 times -3 is -9. Combine, we get a -9. I don't think this is going to work out, guys. -9 times -3 is positive 27. So I get 24. So because let me just double check this one more time. Drop this, that will be a 3. This becomes a 1. That becomes a -3. That becomes a 3. That will be a -9. Now, this just not going to work out. Okay. So because the remainder is not 0, then it is not a factor. But had the remainder been a 0, then this would have been a factor. All right, 11. For the polynomial below, 1 is a 0. Express the polynomial g as a product of linear factors. Okay, so how am I going to do this? They're telling us that 1 is a 0. That means that when it's applied in synthetic division, the remainder will be 0. This will be 0. I'm going to guarantee you this will be 0. Okay. So let's go ahead and do synthetic division. Here we have -4. Here we have -1, -1. As I told you, that remainder was going to be 0. So what does that mean? What does that mean? That means that so far g of x could be expressed in the following form: x minus 1 times constant, linear, quadratic, x squared minus 4x minus, it could be expressed in that form. But this is not linear, so we need to try to factor this. And that's going to take the quadratic formula because I cannot easily factor this. So let's see. If we use the quadratic formula, and I'm just writing it down so that you have it. Using the quadratic formula, then we will be able to say what those other zeros will be. All right, so let's go through this, okay? Negative, negative 4, plus or minus b squared, which happens to be negative 4 squared, minus 4 times a times c, everything divided by 2 times 1. This is a, this is b, and that is c. Oh, my hand is hurting. All right, continuing through this, this becomes, let's just do it here. Let's not be lazy. X is equal to positive 4 plus or minus the square root. We'll do that in a second, trust me, divided by 2. Let's see, that will be 16 plus 4, which is equal to 20, okay? This becomes 4 plus or minus 2 square root of 5 over 2. Where did this come from? This is the same thing as the square root of 4 times the square root of 5. 4 goes into 2 times. 2 goes into 2 one time. So let me write it like so. Oh, come on. All right. There's the other zeros. What are they? 2 plus the square root of 5 and 2 minus the square root of 5. So g of x, let me use a different color. Let me use a different color. G of x could be written as x minus 1, okay, times, we're going to do it like so. I'm going to put a little bracket here. X minus 2 plus the square root of 5, close bracket, open another bracket, x minus 2 minus the square root of 5, close bracket. There we go. Okay. Alrighty then. Moving on. Let's see if we can get some easy stuff here because the other stuff is complicated. Oh, this was good. This is the rational zeros theorem, which says that if we have a polynomial, possible rational zeros are p divided by q. What in the world is p? P is all the factors of -1, while q is all the factors of the leading coefficient. Well, what are the factors of -1? Plus or minus 1. What are the factors of 8? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So this list was going to look like this. It's going to look like, by the way, when we divide a positive by a positive, it will be positive. A positive by a negative will be negative. So in order to, do this relatively simple, we're going to write positive, negative, 1. 1 divided by 1 is 1. A positive or a negative 1/2. A positive or a negative 1 over 4. A positive, negative 1 over 8. So there's the list. There is the list of possible rational zeros. Be sure that no value in the list appears more than 1. Okay, we are sure that that's not going to happen. The function below has at least one rational zero. Use this fact to find all zeros of the function. Oh no. Oh no. This will be P. This will be Q. Okay. So we need to find the list P over Q, which will be plus or minus 3, plus or minus 1, plus or minus 2, plus or minus 4. So we have the list plus or minus 3, plus or minus 3 halves, plus or minus 3 over 4. Okay. Now, I don't know about you guys, but I don't want to test. So what happens is I'm going to use synthetic division to see which ones, and I'm looking at this ones right here, and maybe we could get something out of this, okay? So I'm going to use now synthetic division and test whether 3, let's start with 3, is a 0. So that will be 4, 12, -1, -3. Okay, so I'm going to go quickly through this because I'm checking if, and I don't think I'm going in the right direction here. That would be 60, that would be 72. I'm not going in the right direction here. These numbers are getting too big, and I need this to be 0. And where there's nowhere near, because this is going to be now 71. I'm not going in the right direction there. So let's try now. Let's try -3. Let's see if -3 gives us anything. We get -12. Here we get 0. Okay, I like this. This is somewhat it is somewhat promising. This will be 0. We dropped a -1. A -1 times a -3 is +3. Hooray! Hooray! -3 is a 0. I don't know. Hurrah! That's what I wanted to say. Hurrah! -3 is a 0. What does that mean? It means that g of x could be written so far as, if that's -3, then here will be +3. And then we have constant, linear, quadratic. Remainder, constant, linear, quadratic, always in that order. So we have 4x squared minus 1. And guys, this is factorable. I can factor this, okay? And I'll tell you why. Because let me do it. Let me do it up here. Let me do it up here. Because that is quantity 2x minus 1 square. And that factors into, let me show you. It factors into 2x plus 1. Okay, 2x plus 1. Did I miss one over here? Oh, shoot. I got lucky because I actually missed 1. I actually missed 1. Wow. 2x minus 1. And so therefore, what are the other zeros? Well, we already know that -3 is a 0. All right. Well, now what we're finding is that 2x plus 1 equals 0. 2x is equal to -1/2. Now we're finding that -1/2 is another 0, and that 2x equals 1, x is equal, and that 1/2 is the other 0. So what are the zeros? And I think I got real lucky here. They are -3, -1/2, and 1/2. And I just took a wild guess on 3. I took a wild guess on 3 because, guys, I also miss positive -1, positive -1/2. And I took a wild guess on 3. It didn't work out. I took a wild guess on -3. It worked. It worked. So I got real lucky. If that would have not worked out, then I would have checked this one out because it's easier to do the whole numbers than it is to try to check the fractions. All right, let's move on out of this because I don't want this to be a 3-hour long video. I want it to be quick and to the point. The graph of the rational function is shown below. Assume that all asymptotes and intercepts are on the picture and there are no holes. What are the vertical asymptotes? Okay, well, just to kind of review, that's a vertical asymptote. So is this one. And this is a horizontal asymptote. The equation of that line is, they have to be equations. So vertical asymptotes, that will be, let's start with x is equal to -3, 2, and the horizontal asymptotes in this case will be y equals 0. Okay. Find the domain. Okay. Now that we know this information, we can do the domain in interval notation. In other words, we can choose any value for x except the values of the vertical asymptotes. So in this way, I am showing you that I need to exclude -3 and 2. The range for this example, and this is a little tricky, you see how, in a way, this is a little tricky because this guy right here really does cover all the values of y. So when I might have assumed that y equals 0 would have been skipped, it got covered by the middle section. So here is all real numbers. So that was a little tricky, and you know, it is what it is. All right, so I need to move this kind of out of the way, but because I need to move up the graph. Let's see if I can do it with the mouse. We need to find the x-intercepts. There are no x-intercepts. Let's just check that again. It does. Oh, wait a minute. What am I saying? Right here, buddy. What am I saying? I need to erase that so I can get a closer look. That will be at 1. Oof, I almost missed it again. There is an x-intercept, and that happens to be, x-intercept happens to be 1. Okay, so let me delete this. Going back to the picture. Where are the y-intercepts? There's only one y-intercept, and I see that here. I see that here at 2. So let's go back. Look at that, and that will be 2. Alrighty then. Find all the, okay, so yeah. Okay, we're not listing, we're just saying that this is the x and y intercepts. Okay. All right, moving on out of that. Number 15. Oh, look at this. We just want to graph the asymptotes. Okay. So the vertical asymptote will be x minus 2 equals 0. So set the denominator equal to 0. And we get that x is equal to 2. This is what we're graphing. We're graphing the vertical line given by the equation x equals 2. However, this does not have a horizontal asymptote. It has a slanted asymptote. Again, if I apologize for my handwriting, I'm trying to just kind of get through this. And so let's just see. I'm using synthetic division. So that will be 1, -3, 1. And so I'm going to tell you what happens. Okay, so I'm going through synthetic division. I get -2, and then here I get -1. We're going to discard the remainder. Okay, this will be the constant, and this will be x. So this line, y equals x minus 1, will be the slanted asymptote. So it has a that up over 1, up over 1. So I think that's as good as I'm going to get there. And then bam, 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 bam. Okay, so you go ahead and do that. And that's all you need to do here. That's all we need to do. We're moving on. We're moving on. Now here we need to actually graph the rational function. Back to square one, vertical asymptote. take the denominator, set it equal to 0. Negative x is equal to 4. X is equal to negative 4. We know that the vertical asymptote will be here. It has a horizontal asymptote. Okay? And it's going to be y equals 0 because we're looking at the degree. Think about this. This is x to the 0 power. The degree of the numerator is less than the degree of the denominator. This is x to the 1. So given that, the horizontal asymptote will be y equals 0. Oh, I could have done better there, but it is what it is. And now to the actual plotting of some points, okay? Because you gotta type some points. You gotta type 4 points. So let me tell you how to do that, okay? Let me tell you how to do that. Oh God, it's so bad. That is so bad. Let's do better. Let's do better. Okay, that was a little better. That's a little better, but I'm still not happy, but I'm moving on. Okay, here I'm going to put negative 4. Okay, and this will be undefined. Okay, so I'm going to choose what happens at negative 3, and I'm going to see what happens. No, let me take the, yeah, no. 5 to the left, and a negative 6 to the left, at negative 3, and I am going to say, you know what? I'll choose 0 so that way we can get a y-intercept. Okay. So let's check this out. Check this out. So what happens at negative 5? At negative 5. So negative 4. So f of negative 5. Negative 4 divided by negative 5 minus 4. This is negative 4 over 5 minus 4, which is just 1. And this just becomes negative 4. So we have the point negative 5, negative 4. Okay, somewhere here. What happens at negative 6? F of negative 6. That will be 4. Oh, sorry, negative 4. Negative and a negative makes positive, so 6 minus 4, which is negative 4 over 2, which is negative 2. Okay, so I'm plotting this point here. I'm going to give the computer 2 additional points. Let's see what happens at f of 3. F of 3 will be negative 4. That will be negative, and a negative will make, again, negative 3. Positive 3, so that'll be 3 minus 4. So we get negative 4 over negative 1, which is equal to 4. So I should have been putting these numbers here. My apologies. This was negative 2. Negative 3, 4 up here. And then f of 0, just because we want to get a, a nice, also an intercept here. We got negative 4, 0 minus 4. That will be negative 4 over negative 4, which is 1. So we got 0, 1. And then we let the computer do its thing and said, hey, graph it using these 4 points. And the computer will do something like this. This will be the branches that they, oh, of course, you get the idea, right? You get the idea. But once we know where the vertical asymptote will be located, I chose 2 x values to the left, 2 x values to the right. I plotted those points, and then we got to work. Okay. All right. Moving on. 17. Okay. This one's also similar. Let's see what kind of jelly jams we get ourselves into. Vertical asymptote. Negative x plus 4 is equal to 0. Negative x is equal to negative 4. X is equal to 4. There we go. It has a horizontal asymptote, and that asymptote is going to be 2 over negative 1, which is negative 2. Why? Did you notice that in this case, these powers are the same? So therefore, if those powers are the same, then the horizontal asymptote will be 2 over -1, which is y equals -2. So same idea as before. Right in the middle, I am going to put 4. I'm going to write undefined. I'm going to choose two x values to the left and to the right of 4. To the left, 3 and 0. Here, 5 and 6 to make my life easy. Okay, for that. And so let's start with 0, 0, 0, 0, 0. F of 0. That will be -6 over 4, which is -3/2. So 0, -3/2. That's like 1.5. -1.5. So that's right over here. Again, you can just type it on the computer and the computer will do it for you. F of 3. 2 times 3 is 6. 6 minus 6. That will be -3 plus 4. That will be 0 over 1, which is 0. 3, 0. Okay. Right here. 5. Let's see f of 5. 2 times 5 is 10. 10 minus 6 is 4. Again, 2 times 5 is 10. Minus 6 is 4. Then we have -5 plus 4, which is 4 over -1, which is -4. 5, -4, right over here. F of 6, so -4. F of 6, that will be 2 times 6, which is 12. -12 plus 4, that will be 6 over -8, which is -3/4. So 6, -3. Whoa, something didn't come out right over there. 6, 6. Something. I'm not doing something right. I'm not doing something right. Oh, why did I put 12 here? Wow. Why did I put 12? Okay, let's do that again. So 2 times 6 is 12. We got that. Then that would have been -6 plus 4. So here we get 6 over -2, which is -3. Oh, wow. I got scared for a minute. All right. Because that other point would have put it up here, and that would have been funky. So the thing will look like so. Wow, this sketch is so bad. But again, you guys are doing this with the computer, so it will look beautiful. Okay, there it is. Enough of that. I am moving on. Let's move on to the next thing. 18. Below is the graph of 1 over x squared. Here's some transformations. This one became a 2. I will address it in a minute. X squared, but then there's this -4. Okay, this -4 is down 4 units. But here it is, the x values will remain the same, but the y values are going to be multiplied by 2. That's what that means. So for what you want to do is you want to do this. You want to do the stretch because it is a stretch. You want to do the stretch. So let me show you. So in this case, you see how this goes through 1, 1? Well, because now the y values will be multiplied by 2, then this point will become, let me use a different color. That point will become, let's see if this one will become 1, 2. So then you kind of stretch the graph. And then you move it down 4 units. So then 1, 2, 3, 4. All right, right here. So this thing, in whatever way, so 1, 2, 3, 4. So we have, this will be the horizontal asymptote. So this thing is just going to look like so, like that. And it's going to look like that, okay? Oh, wow, that's horrible. But hopefully the tips here help you out. In this case, this was moved down 4 units. This means that the y value got multiplied by 2. So what you need to look out for is first do the stretch and then bring it down, okay? All right. All right, enough of that. Ooh, some inequalities. All right, let's get down to some inequalities. Okay, so this would have looked like so from the beginning, okay? That would have looked like so. What we do is that we tend to factor this quadratic expression here, which is what it is over there, okay? And so now that we have this, we kind of tend to forget that we're solving an inequality, and instead we spend a little bit of time solving that equation. Well, this was not so difficult because since it was already in factor form, we can find that x will be equal to 0 and x will be equal to 5. What does that mean? These numbers act like test points. We have a number line and it kind of breaks the number line into sections. So in this case, I am going to put a solid circle here, solid because of the equal to, okay? But had not that been an equal to, it would have been an open circle. So here I have a filled in circle. Also at 5, we have a filled in circle. So basically the number line has been broken into 3 sections. And we need to test which sections make the inequality true. Some time right now. Which ones make the inequality true? So here, let's pick, for example, what happens when x is equal to, I don't know, I'm going to make this simple. I don't want to make this complicated. -2. Will -2, in other words, will choosing any point to the left of 0 make the inequality true? Well, let's test it out. Let's test it out. That will be -2. I guess I should put that in the parentheses so I don't get confused. That will be -7. Negative and a negative is positive, so that will be negative, positive 14 less than or equal to 0. This is false. That is false. Let's see what happens when we check 2. In other words, what happens when we test any x value in between 0 and 5? Okay, let's test 2, see what happens. Let's see what happens. We have -3. That will be -6, and -6 is less than 0, so this is true. What happens when we pick, for example, 10? What about the numbers to the right of 5? What happens there? Well, let's check that out. That will be 10. 10 minus 5, is it less than or equal to 0? 10 times 5, this is equal to 50, and 50 is not less than 0, so that will be false. So this is the only part that is true. So all of this will be the solution. And in interval notation, that is, bracket 0, 5, bracket. The only difference, for example, if we would have had that as the example, then instead of brackets, it would have been parentheses, and the solution would have open circles, in that case at 0 and at 5. So this would have been the solution. I'm just going to try to highlight it, but there would have been open circles instead at 0 and 5. Okay. Alrighty then. Moving on, let's see what kind of jelly jam. We got an inequality here, and I don't know where these other examples are coming from, but sure. We'll work them out too. All right, so how to solve these type of inequalities? First of all, okay, we're trying to find the values of x that make the left side greater than or equal to 0. However, by solving this equation, we know, oh, sorry, we know that -4 will never be part of the solution. Why is that? If x is ever -4, the denominator will be 0, and we cannot divide by 0. So right now, from the very get-go, I'm going to say that here will be -4. The x can never be equal to -4. All right, so let's see. X minus 7 equals 0. X is equal to 7. So the value, in this case, 7. But this one, because we're not talking about the denominator, okay? This one is actually going to be a filled-in circle. Why is that? The reason for that is because we go by the inequality symbol. We go by the inequality symbol. And this inequality symbol says that it's greater than or equal to. So in that case, it will be included in the solution set. Okay, so. Okay, +7, +7. All right, enough of that. All right, so now we know where to break the number line. Okay, so notice that it was as simple as the denominator equal to 0 and the numerator equal to 0. It's as simple as that. Okay, and now back to the same game. Let's see what happens. Let's see what happens. Okay, and I'm going to give you a technique. Okay, a shortcut right now. I am really interested in what happens in the middle, and I'm going to say that definitely x equals 0 is here. Because if it doesn't work in the middle, that means it's got to work on the outsides. Hopefully you know what I mean by that, okay? But all right, so let's see what happens. So 0 minus 7, 0 plus 4, and that's going to be -7/4, which this will be false. It will not work. So to speed up through this process, hopefully I can use this highlighter. This is going to be the solution, and that's going to be the solution. If the middle fails, then automatically the outsides will work. Okay, so that will be -infinity, -4, parentheses, union, bracket, 7, +infinity, because we have to skip all of that. Hopefully I didn't confuse you, but if I did, hey, by the way, you can test -5, and over here I recommend you to test x equals 10 so that you can see that it will work on the outsides. All right, I'm moving on, and let's see what's going on here. It seems like we're back to square one with find the domain. Okay, simple. The domain will be all real numbers. Okay, so not bad. The range will be the values that are going or greater. The y values will be greater than equal to 3. Okay, that was easy. 22. Oh, okay. Okay. What do we got here? We want to graph a parabola. Why do I feel like this should have been questions at the beginning of this? But it is what it is. And so there we go. Okay, so okay. All right, so here we go. All right, so let's go ahead and graph this. Let's see. I wonder 3 times 7 is 21. And then that's as good as it's going to get there. So we're just going to have to find the vertex. Find the vertex. Negative b over 2a, f of negative b over 2a. Okay, and the vertex will be, first of all, before I do that, it opens up. It opens up because the leading coefficient is positive. So it opens up. Let me write this a little nicer. I mean, it's already a long video anyway, so might as well just take my time here. All right. I want to find the vertex by using this formula or this technique. I guess I should call it technique. Doesn't matter. It's my video anyway, so I'll call it formula. Okay. Oh, my stomach is grumbling. Okay. So this will be A. This will be B. That will be C. The vertex will be, let's see what happens. Negative 12. 2 times 3 will be 6. Okay. So that will be negative 2. And then we need to know what in the world is f of negative 2. Okay. So let's plug that in. The y value will be 3 times negative 2 squared plus 12 times negative 2 plus 7. This will be 4, so that will be 12 minus 24 plus 7. This is negative 12 plus 7. We get negative 5. I get negative 5. So the vertex will be negative 2, negative 5. Negative 2, negative 5 right over here. We know that it opens up. We know that it opens up. Okay, so it opens up. So very similar to what we did before. Okay. Okay. Two, three, four, 5. Here I'm going to put negative 2. Here I'm going to put negative 5. And I'm going to choose some values to the right. And I'm going to choose some values to the left of the vertex. Negative 3, negative 4. And I'm going to plug them in. Okay. And so let's see what happens when we have 0. That's actually not that bad. F of 0 will be 3 times 0 squared plus 12 times 0 plus 7, which is just equal to 7. This value right here will also be 7 because it is symmetrical. Okay. And so if we have 0, 7, which is up here, okay, we will also have negative 4, 7. Okay, that's not enough. I mean, if the computer could do it, but we're going to give some other values. Let's find what happens at negative 3. Actually, I'm going to do negative 1, okay? 3 times negative 1 squared plus 12 times negative 1 plus 7. This just is, this is 1, so that becomes 3 minus 12 plus 7. That will be negative 2. And so if that's negative 2, then this will also be negative 2 because it is symmetrical, okay? Notice that negative 1 and negative 3 are the same number of spaces away from negative 2. So it is symmetrical. So we said negative 1, negative 2, and negative 3, 2, negative 2. And so there it is. Let the computer graph it for you. All right, so you got to give it 5 points, I believe. So you got to give it 5 points. 3 would have done it, but I think you got to give the computer 5 points. All right, there's that. Find the x and y intercepts of this. Okay. All right. X intercepts. Let's do that. Y intercepts. Let's go ahead and do the easy ones first, right? Actually, they're not going to be that bad. They're not going to be that bad. So let me start with the x intercept. To find the x intercept, we are going to solve that equal to 0. This factors. 3 times 1 is 3. And -3 and -1 and -3 will combine to -4. Oh, yes. Okay, so I'm going to this, and I'll get 3x squared negative x minus 3x plus 1 is equal to 0. So I think I'm probably skipping a lot of conversation about, oh, this will be factorable, and then we can split the middle term. And here we're using grouping, factoring by grouping. And so we get 3x minus 1. 3x minus 1 with a -1 in front of it. And we get x minus 1. 3x minus 1 equals 0, which gives us x minus 1 equals 0. 3x minus 1 equals 0. X is equal to 1. X is equal to 1 over 3. So the x-intercepts are 1 and 1 over 3. It doesn't matter the order. It just wants you to list them out. So I recommend you that if I went too fast to the factoring, that you go back, just think about how you would do that. Think about how we've been doing this. Okay, I'm just gonna move on. Y-intercept. To do that, we find f of 0, which is 3 times 0 squared minus 4 times 0 plus 1. That goes away, that goes away. F of 0 is equal to 1. So that means that the y-intercept is 1. Okay. And that's it. That's it. Don't overstress that. This is much easier to find. And the x-intercept takes a little bit more work because we're solving a quadratic equation. Okay. All right. So number 24, it seems like it's just picking some stuff here. All right. Okay. What in the world? Okay, so for G, okay. Let's see. I think I'm not really a fan of this particular example, but it is what it is. For g of x, we have 2x to the 4th power minus 18x squared. We can factor a 2x squared, and we'll get x squared minus 9, which we'll get 2x squared x plus 3 x minus 3. Okay. Okay, so what we're looking at is this. Okay, we got 3 zeros. 2x squared is equal to 0. X plus 3 is equal to 0, and x minus 3 is equal to 0. And here we have x is equal to 0. Okay, so what I need to explain to you about what's going on here is that because of this square right here, 0 has multiplicity 2. Multiplicity 2. And what does that mean? It means that when x touches, let me take that back. When the graph touches the x-axis at 0, it will bounce. It will bounce. In this case, because these zeros are happening, the graph is crossing the x-axis at those values. But because, as I was trying to explain earlier, because of the leading exponent being even and the leading coefficient being positive, both ends will rise. So right now I'm looking at graph A, and graph A doesn't represent this information. Okay. Although both ends are increasing, it's not representative of what's happening at the zeros. Look at B. It is crossing at -3. It is bouncing at in this case at 0 and it is crossing. So I like B as the option for g of x. Okay, for g of x. Let's just look at, no, definitely not that. Definitely not that. Okay. Let's now inspect, and let's do that here at h of x. H of x is x, okay. We have x squared minus 9. This is actually x plus 3, minus 3. If we take the powers of x and we add them, that will give us 3, which is odd greater than 1. Because the leading coefficient is positive, then that means that it will fall to the left and it will rise to the right. But at the zeros, x equals 0, x equals -3, x equals 3, there is no repetition, so the graph will just cross. So it will cross at -3, it will cross through 0. So let's look at the pictures. Notice that, oh, I like this one because it's crossing to -3, it's crossing through 0, and it's crossing through 3, and it's got the left down, what is it? Falls on the left, rises to the right. Let's look at D just to make sure. Yeah, that would have contradicted our end behavior. So C is H. All right, let's look at the last one and call this quit. Oh, we missed one over here, but that would have not been us. That would have not been us. Solve the inequality. Okay. All right. Let's go ahead and take care of this quickly. We have, okay, this, I'm going to write here -5, -3, and 7. Okay. We have -5, -3, and 7. So it's just going to make us do a little bit of testing some intervals and see what happens. So let's do that. Let's choose x equals -6. -6 plus 5 is -1. -6 plus 3 is -3. -6 minus 7 makes it -13. And this will be a number that is negative. Okay. And a negative number is not greater than 0, so that will be false. Let's check out what's going on here. Let's use -4. Let's use -4. -4 plus 5. So let me go ahead and get rid of this before you guys get confused here. -4 plus 5, that's 1. -4 plus 3, that's -1. -4 minus 7 is -11, and this is a positive number, and a positive number is greater than 0. I'm going to choose 0 here because clearly 0 is between -3 and 7. 0 plus 5 is 5. 0 plus 3 is 3. 0 minus 7 is -7. This turns out to be a negative number, and that will be false. Positive times a negative will be negative, so that's not going to work out. Let's see what happens when we choose something to the right of 7, like 8. 8 plus 5, that will be equal to 13. 8 plus 3, that's 11. 8 minus 7, that's 1. This will be a positive number, and it will be greater than 0, so this will be true. I almost wrote the wrong stuff. So the interval will be, solid circle, solid circle, solid circle, and this will be bracket -5, -3 bracket. But here we get a bracket 7 positive infinity. So we'll get the interval from -5 to -3 union from 7 until forever. And that's it. I'm going to call this quits. Call me out on any mistakes. It is what it is. You know, I am human. I am done working with this. I hope this helps you out. And what I'll do is I am not a fan of this question. Where is it at? Where is it at? Where is it at? Where is it? Where is it? I am not a fan of this question, so I am going to make sure that I look at the exam to make sure that you're not being challenged with something that is I'm going to look at that on the exam to make sure that if we do come across something like that, it's just simple. Or maybe we could just even take it off the exam. But be on the lookout. Let me know if I made any mistakes. It's been a pleasure. Bye bye.